Welcome, my name is Claudio. I'm a program manager in the Azure Hyperscale team. And today I'm here to present one of the programming models that are available for a new, very cool technology that is called Service Fabric. So today we are going to talk about this technology. It was announced last week, so you probably had the chance to read about it. And you might also have seen this slide. This is basically what Service Fabric is. It is a new framework, a new runtime environment that is designed to allow high scalable microservice-based application to run on Azure and also on-prem. As you can see, there are a lot of different features that comes with the application, with the framework itself. There is high density, there is high availability, the ability to scale the application, or all features that are built in the platform. In addition to that, there are also different programming models, different way to write application for this specific platform. And today we are going to discuss one of them that is called what we call the reliable actors. Let me move very quickly, a very brief introduction if you are not already familiar with the actor model. It's not a new idea. It was invented about 40 years ago by Carl Hewitt. He basically designed this, he thought about this new model of building application that was based on independent units where both state and code could be encapsulated together, and then communication was done through some sort of messaging system. So that this model became very, very interesting in the last few years because of the new requirement of highly scalable application. There are now, with cloud solution, you can potentially have access to hundreds of cores. So now the challenge is how to build application that can really leverage that sort of powerful infrastructure. And actors seems to be one way that you can design application that really allows you to leverage that very powerful infrastructure by keeping somehow the idea, the design of the application relatively simple. In addition to this encapsulation of code and state, asynchronous communication, actors also provide the ability to run single-threaded. So an actor is supposed to be single-threaded. So the complexity of designing and dealing with multi-threaded type of application is something that you can avoid with the actor model. There are various implementations, both in the sort of .NET world, but also on the other runtime environments. Probably one of the most famous one is the one used by Erlang. So let's dig a little bit into why we need an actor model. So in the old days, the application were built in multiple layers, typical three tiers type of level. There was the web front end, there was a middle tier or a business logic or an application server type of layer, and then there was an access database and storage layer. The challenge with that type of model was really dealing with the scalability of the application. So typically, the application maybe becomes very famous, more customers want to connect to it, and then what happens is that the first layer probably is the web front end and needs to be replicated to be able to handle more traffic. Then, the next level will be probably the application server layer, and then the database layer. And in each of these steps, as a developer, it was always challenging to try to find the right trade-off between adding more components, like maybe a queue system in order to pipe and queue request, and maybe cache systems in order to provide low latency or reduce the latency for end users. With the internet skate or cloud native type of applications, what happens is that the idea is to build an application in a very different way. And the way is to create something that is provide a finer granularity over the components in the application and try to build basically what now is called as a microservice architecture. So basically split all the functionality in your application in multiple small manageable components that can potentially be replicated based on the workload. And the idea is to provide the elasticity, the scalability based on demand in such a way that the system somehow is able to react automatically based on the demand. So on the right, you see that there is this sort of a new idea where you have typically a front end. It can be a load balancer or something that provides the public endpoint. And then there are machines, can be, a cluster, what we can call a cluster. And inside that cluster, there are multiple independent components that interact with each other in order to provide the functionality required. So in this new model, we have the service fabric that is the underneath infrastructure, so that sort of cluster management runtime that we need. And then we have the fabric reliable actors that are the programming model that we can add on top of the runtime in order to build our applications. And then being based on an actor model type of design, we get some of the feature that comes with the actor model. And typically the resource isolation, as I was saying before, the ability to encapsulate state and code together, the asynchronous communication, okay, that is very important in order to achieve scalability. And also they are single threaded. So when I write the code for my actor, I don't really need to go into complex multi-threaded type of code that clearly is very difficult to write and get it right. So in addition of being based on the service fabric, what we get is some additional benefit. And one of them is, for instance, location transparency. Location transparency basically means that in order for me to be able to interact, to send, quote unquote, send a message to an actor, I really don't need to know where that actor is going to be located within my cluster. I have a very easy way to, quote unquote, bind to that actor in such a way that I don't really need to manage from a developer, from my application point of view, the actual location. So being able to keep track of where my actors are going to be allocated. In addition to that, we basically built the asynchronous communication model is also based on a request response type of pattern. So it's very, very easy to use. I send a request to an actor. The request is going to be asynchronous, so it's not going to be blocking from my side. But at the same time, I have this pattern of request response. So I know that I will get a response back. So the logic in my code doesn't need to really have to deal with complex asynchronously being able to track, for instance, what type of message I sent in order to be able, for instance, to process a message coming back from another actor. And then the thing that is built in Windows Fabric is the automatic failover. So I have an actor. The actor might fail for some sort of reason. It can be the code itself that is failing, or it may be that is the node where that specific actor was running that is failing. And what the Windows Fabric infrastructure does is automatically reallocate the actor on another node, or potentially restart the node, the actor itself, in such a way that from a developer point of view, I don't have to deal with this sort of failover type of scenarios. In addition to that, another important feature is I have the ability to upgrade the actors in a what we call a zero downtime type of fashion. So I have a running service. The service is composed of multiple actors. The actors can be upgraded over time without any interruption. The worst case scenario is the users on the other side will see a very, very small pause in their sort of interaction with the backend system, but nothing is sort of lost. I don't need to restart a machine. I don't need to go through complex deployment process. So all of these are benefits that comes with the actor model being built on top of the service fabric infrastructure. So let's see what more in detail, what does it mean to build really an actor-based solution. So in order to build a reliable actors application, the first thing that I need to do, and you will see that the process that I'm following is something that is really should be very, very familiar. It's nothing really new. It's very, very similar to the same process that you go through by building a standard object-oriented based type of application. So the first thing that I do is I define the actor interfaces. So basically the actor interface define what we can call quote unquote the messages. So the type of messages that the actor is able to process and will allow a third party, that can be a client application or it can be another actor, to interact with that specific actor that I'm about to define. Second step, I just need to implement the interface in a class that derived for something that is called an actor. So basically you take, like you will do in any sort of object-oriented type of application, you take a class, you derive from it, you implement an interface that basically define the business logic, the code that define my actor. In addition to that, we will see, I have a slide about that later, that we also see how we actually going to package these actors together in such a way that they become quote unquote a service, so an entity that can really run inside the service fabric infrastructure. Then the third step is I need to register the actor, and basically registering the actor means that I let the service fabric infrastructure know that there is a new quote unquote type, a new entity that can be instantiated. So any other application, service or program that is running within my service fabric infrastructure will be able to use this new entity. And then the last step is in order to communicate with actors, so if I want to invoke one specific message, I want to send a message to an actor, the way that I do it is with something that we call an actor proxy. And the actor proxy is the class, the entity that provides that sort of location transparency that is an additional benefit of the actor model running on top of the service fabric. So I really don't need to have a complex business logic in my application in order to handle where, and to manage where actors are located. I can use the actor proxy. The actor proxy provides me all the ability of, failover management. So let's assume that I'm working with an actor. That specific actor is also on one node in the cluster. That node might fail. So the actor is reallocated to another node. By using the actor proxy, I can just call the actor again. I don't really need to figure out or even know that that actor was actually moved to a different node. So the actor proxy provides a very, very easy way to interact with actors. Actor proxy is used both by client application, and we will see different types of client applications, but also between actor to actor type of communication. So before we go into some real code that we can show, I want to spend 1 minute to explain how applications and services are really packaged and deployed on the service fabric infrastructure. So in this case, I have a set of actors that I define. I can, I have a lot of flexibility. I can decide that, one actor is one service on this service infrastructure, or I can package multiple actors together in one single service. So I have basically one entity that I take all the code, I package together. Potentially, I might have also some configuration, some data that I need to package along with my code. I package in something that is called a service package. And then I have an application package that is basically my logic unit of deployment for service fabric. And what the application package gives me is basically three different things. Number one is the unit where I can manage the lifetime of my application. So an application is deployed, an application is activated, an application is deactivated, okay? The second thing is versioning. So an application defined, I can have multiple versions of an application. And then is the logical unit in which I want to version one specific set potentially of services. So if I have a set of services that define maybe my end-to-end solution for a customer, that becomes an application that I can rev. I can deploy multiple versions of that by taking care of managing all the different components as one single logical unit. And then at the same time provides isolation. So the application itself and all the services inside the application can run within specific, for instance, security requirements that are customizable at the application level. So I have really a very fine-grained type of control over how I package my different services that, by the way, I can reuse across multiple applications, or how I configure that specific application in order to run in the service fabric. So once I have my service package, I package them. I can have multiple, in this case, I have 2 services, and then at that point, I have one single unit that I can deploy in the service fabric infrastructure. So let's go and show some code. So the first thing that I want to show is how the developer experience looks like. So first of all, for Service Fabric, the typical developer environment is composed by clearly Visual Studio with Service Fabric VS Tools. So it's a new project system that allows you to write different type of Service Fabric services and applications. And then is also based on a local cluster. So on your local machine, in this case my laptop, I have the same runtime environment that I can deploy, that can be deployed on Azure, for instance, on multiple machines. Everything is running on the same box. It's sort of similar to the Azure emulator sort of thing, but is very, very close to what the real runtime environment is going to be. So an application that runs on your local cluster is going to run as is on a production environment on Azure. So here I have Visual Studio. I installed the Service Fabric VS Tools. So let me first of all show the canonical Hello World type of application. So once you go into the Visual Studio environment, you have clearly the ability, so let me show very, very quickly, the ability to create a new project. So under Cloud, there is a new category, Service Fabric, and you see that you can create different type of services. So the Visual Studio tools for Service Fabric will provide you a set of templates that you can use in order to quote-unquote jumpstart the type of service that you want to build. In our case, you see that I will focus on the Service Fabric actor service type of projects. So here, just to save a little bit of time, I pre-created the typical Hello World type of scenario. So let me show what our solution will look like. So I have, first of all, we discussed the step number 1 is to define the interfaces. So when I create a solution, I have one project in my solution that defines the interfaces. And here you see that I have, in this case, Hello World interface is very, very simple. I have one single method that is say Hello World. And the only thing that I need to do is to derive the interface from iActor in such a way that the Service Fabric infrastructure knows how to handle and how to manage these interfaces. In this specific case, when you create a new project, the template creates a simple interface already. So what you can do is just to customize and the code that is already provided by you by Visual Studio. So after I have the interface, so in this case, I as I said, I create only one method that is say hello. I go to the next part of the application that is, in this case, the Hello World. And the Hello World is what we saw just before in the slide before is the service. So it is the logical unit where the actor is going to be packaged inside in such a way that it becomes an entity that can run inside the Service Fabric infrastructure. So the thing that I need to do in this specific project is, let me actually take the Hello World actor. So you see that here I have my actor. I have the Hello actor. It derives from one specific class, that is the actor class. And then the thing that I'm doing is to create and to implement the Hello World interface. So as you can see here, Visual Studio already pre-created some boilerplate type of code that is the typical code that you need to have within an actor. And let me walk through very, very quickly some of the built-in methods. So we have a method, for instance, that is called onActivate. This method is called when the actor is going to be activated by the runtime environment. So here, for instance, you can write some initialization code that you might need to have in your application. Typically, you might have a config file where you read some parameters, or you connect to some sort of external backend system in order to collect some data that needs to be available while the actor is up and running. There is another method that is the activate. So when the actor is going to be deactivated, I will spend a few words later to explain what that means. And then, as you can see here, I have basically the implementation of the say hello. So say hello in this case basically take one parameter, and what I'm doing is basically just sending back to whoever is calling me, in this specific case, basically one string with the greeting that I got with a string. So it's very, very, very simple implementation. So one more note, you see that here I have also this class, service event source class. This is something that comes again with the template that is generated by Visual Studio, and basically give you the ability to create ETW events that can be used for logging and tracing type of scenarios. So along with being able to debug my application, I also have the ability to have a very rich ETW set of events that I can fully customize in such a way that when my application is deployed at runtime, I have the ability to figure out what is going on with my system. So I have this application, and then let me show you the thing that doesn't come by default yet. We are going to add that by next week for build. So here is the client application. And let me show you before we go that, let me show the third step. I forgot to mention that. The first step, if you remember in the previous slide, was about registering the actor. And then here it is, how it is done. So I have basically one class that is provided by the runtime. And then during that class, I do the actor registration. At that point, basically, with this line, I basically making my actor available to all services and application running on the Service Fabric infrastructure. So by default, the Visual Studio solution create one for you, but if you implement multiple actors in the same project, you will have basically to add additional lines like this in order to register the additional actors that you might have in your application. So we went through the interfaces, we saw the actor implementation with the interface, we saw the actor registration, and then the last step, the fourth step, was basically the actor proxy. So in this case, in the application, I added a client application just to test that actually the actor is working. And then here you see that is the way that I'm using the actor proxy. So the actor proxy gives me the ability to connect, to bind to an actor, and this is basically how I do it. I have an actor proxy, I say create, and create doesn't always mean create. Create means create if the actor is not active, or it means quote unquote bind if the actor is already running. I specify the type of interface, so what type of communication I want to have. So in this case, I want to communicate with the hello world actor, and then basically, I define an actor ID, I specify an actor ID. I will spend a little bit of time later to explain what that means. And then I have the application name that basically define the application as I showed before in the previous slide. That is the entity that encapsulates, that package the different services in my application. In this case, I have one application that is composed of one single service. So I want to show you one quick thing. So let's go to the hello world, say hello. I can, for instance, set a breakpoint here. I go to my hello world application. You see this hello world application is the Service Fabric application. It is the application that manages the entire life cycle of my application. So the build process, the deployment process, the debugging, and so on. So by default, it is the startup project. So the only thing that I need to do in this case, if you see here, I have the ability to for instance, deploy, remove a deployment, package my application, and do additional operations on my application. So the thing that I need to do, like any other Visual Studio application, I just need to hit F5. And what this is going to do is basically to package my application, so compile the code, package the application, so basically build that sort of application package that I showed you before, and then basically take the application and deploy the application on the local cluster. And as you can see on the output window, the Visual Studio is telling me what is happening, so how the process is progressing over time with my package being deployed on the local cluster. And then here you see that I have the diagnostic events that basically show me all the ATW events that I used in my application. So I can very easily see what is happening on my application. So now I have the Service Fabric application is deployed. My actor is ready to be used. So let me switch very quickly to the Hello World client. So I have a very simple console client. So here, Hello World client. So now what I'm doing, I'm launching the client application. And as you can see, like any other Visual Studio application, the actor proxy call the actor, call the say hello method, and then in the say hello method I have the breakpoint. So I have the ability to debug my application like any other Visual Studio application. So and then here, as you can see, I basically from the client application I have, that is the ID of the actor that I was calling. Here, there it is. And then basically, actually I didn't send any message, but this is basically the reply that I got back from the actor. And then as you can see here, I have all the, for instance, this is the ATW event that I registered in my say hello world method when it was invoked. So here you can see that I have the ability to very easily see what is happening in production with a set of ATW events. Okay, so this is a very simple example. I want to spend one more thing. So actually, let's kill this. I want to load one different solution. So let's take this solution. Is exactly the same solution. So one thing that I want to show you is, I said a lot about actors, but there is one specific thing in the name of our new technology that is called reliable actors. So I want to show you a little bit about what that means. So here I have another project. It's a very, very simple actor. It's an actor that has, let me show the interface here. I basically have the ability to get and set. So it's a counter. So I have an actor that basically save a local state, a counter. So I can read the counter or I can set the counter to a new value. Okay. So it's very, very simple. I have a client application. I have the interfaces like before. So let me do a very simple here. So instead of going through the debug process, at this point I don't really need to go to the debug process. I just want to deploy this solution. So I go to deploy. So now what happens is that my application is going to be deployed on my local cluster. Okay, so let me go to the client application. Here it is. So here I have my counter application. So, and if I start my counter application, you see that is very, very simple. It's going to call the actor, it's going to get the state, increase the counter by 1, and just keep calling it, okay? So, now, let me show you how the application will look like. So there is a very, very interesting tool that is part of the Service Fabric infrastructure that is called the Service Fabric Explorer. And with the Explorer, I can actually see what is running inside my Service Fabric infrastructure. So in this case, I have, I have my application view. You see that I have the Hello World application that I deployed before. And then I have this application that is the counter application, and you see that this is basically telling me that it's running on node 1. So let me show you what the cluster look like. So in my local machine, I have the Service Fabric infrastructure is basically right now based on 5 different nodes. So think of like 5 logical machines connected together. And then I have that the application, the Fabric application, the specific counter, is currently running on node number 1. So if I go on node number 1, I see that there is the counter application. I go and actually I see that this is the code that is actually running on that specific node. So let me make a little bit of room here. So you see that I have my application is running. So let me do something like I want to simulate the failure. So I have actually let's move this a little bit here. Okay. So I want to show a failure. So what I'm going to do is here. You see that I have node number 1. I have code, and basically I just say restart. And what this means is basically just a process restart. I have a process that is running here, and I want just to kill it and restart it. So I restart it, and then what I should see is, you see that, I have my application. Let's stop here. Automatically my process restarted. The actor actually lost the state, but he was able to recover from a failover, and you can think of failover as the node actually failing or the process failing itself. But you see that the Windows Fabric infrastructure was able to restart the process and basically get everything up and running, and the client application basically didn't see anything happening, sort of, right? The state clearly is different now, but from the application point of view is like the actor was always running. So let's move back to the slide deck. So what I showed you here is basically the basic end-to-end developer experience, and then also the first very important concept, that is the code is reliable. So the Service Fabric infrastructure is able to manage the failover of services when something happens to the code execution. So in this case, you see that the service failed, and actually I made it fail. The Service Fabric, what it does is potentially relocate, in our case, the actor service to another node if that specific node is failing, or it can restart the process in such a way that it guarantees availability. So from a client point of view, there is nothing, or from the application itself point of view, there is no additional business logic or complex logic that I need to build into in order to handle that specific scenario. But, as you saw, when the failover was happening, what I did is I actually lost the state. So, having a in-memory only type of state is interesting, but for a real case scenario, I need to have more than that. So let me show you what it means to take a stateless actor and make it stateful. So it's a very simple two-stage process. So number 1, I define what I mean by state. So I take what I consider to be the data that I need to persist over potentially failures or restart. And then the only thing that I need to do is to take that class that I implemented before that derives from an actor, and I derived from an actor of T state. That basically define now the actor is actually an actor that as a state that I need to save and replicate. What the actor, the reliable actor, has built in and provide out of the box is automatically the management of the state. So for instance, I have any change that is made to the state automatically is saved and replicated in such a way that if something goes wrong with my actor, I have the ability to restore the state as is. And then I have the ability to optimize the control over state. Like for instance, state is persisted every time that there is a method. So when I call a method in my actor, the method might change state. So what the Service Fabric infrastructure does is actually to save the state. But if I have, for instance, a method that I know that is not going to change state, what I can use is something that is called read-only. So I mark that specific method as read-only. So that means that is not going to change state. So the Service Fabric infrastructure can avoid doing the actual state replication and things like that. So performance-wise, you definitely can benefit from that. And in addition to that, you can have, as a developer, fine-grained control over state. And when you want to persist and save state, so it can be quote-unquote on demand if you need to. So let me show you very quickly what that means. So I have, let me close this solution, and I want to open another solution that is the this one. So here I have basically is exactly the same application. So the only difference is I want to show you that is the two things that I need to do in order to create a stateful service. Number one, here you see this class counter state is the step number one. So I define what I mean by state. So in this case, it's a very simple integer that I want to save. It can be, you know, as complex as you want. It just needs to be a class that is serializable. Okay, and then here you see that the only difference that I need to make is I need to specify that now my actor is a stateful actor. So the stateful actor with the state that is the counter state that I just defined. And then here, the only difference in the code is my state is exposed, quote unquote, with a member, a class member that is state. So with the state, I can basically access the counter state class, and from there I can read and write, I can set or get all the method there. So beside that, there is nothing else that I need to do. So let's go ahead and take this application and deploy it again. I deploy on my cluster. So I'm going exactly through the same process. I take, package the application, deploy on the cluster, and then let me show you. First of all, let's open the client application and let's get started. Okay. So here I have basically counters is basically going over, is increasing the counters over time. Okay. So let me show you one important thing. So if I go to the Solution Explorer, Service Explorer, let me do a refresh. And then here, now I have the same application because I use exactly the same name to identify it. But let's show here what happens to the deployment. So before you saw that there was only one node active. Now, because I asked sort of in a sense the service fabric to take care of the state, at this point you see that my deployment is different. I have now 3 nodes. I have one node that is primary where my code is running, and then I have 2 other nodes that are called secondary. So it's where those nodes are used in order to replicate the state of my actor in such a way that if something goes wrong with node number 2 where my primary is running, I have the ability to recover, so recreate the code, restart the actor, and basically rehydrate the state from one of these 2 secondaries that are running at the same time. So this is basically the typical scenario where you have a stateful service. Clearly, the number of replicas where the state is replicated can be configured. In this case, I decide to have basically a scenario with 3, so a primary and 2 replicas, but I can have 1 primary and multiple replicas if I really need to guarantee a super high level of reliability for my state. Okay? So in this case, I have, the counter is actually running. So let me actually show, first of all, another application. So if I go back to the same application as before, so I have the counter. Let's run this one. Is like before, that I was showing before, that it was just increasing the number. But this time, let's go through the same process and try to see what happens if I restart this primary. So I go to, in this case, node number 2, because now my code is running on node number 2. I have code, and then basically I restart the actor again. So I want to that you notice one important thing. Let me stop here. You see that the big difference with respect to the previous example is that what I see today now is that the counter actually continued and was not restarted. Because yes, the code was restarted, I killed the process restarted, but the state was preserved, was saved in the 2 other secondaries that were running along with the primary. So as soon as the actor restarted, it was able to recreate the state like it was before the failover process. So this is a very quick way to show you how you can build actors that can actually also preserve state across potential failovers. So let's have a quick note on stateful actors. So the way that actors are persisted is something through what we call providers. And there are two built-in providers in the service fabric. So the the reliable actors framework comes with two providers. One is volatile state provider. This means that the state is replicated, as you see across multiple replicas, but is in memory only. So in that case, if all three nodes goes down, the state is not going to be saved. So this is, again, it works well for all the cases where you need to preserve the state, but in a sense, you can afford to lose the state if there is a drastic or a big failover type of scenario. Or there are the durable state provider, where along with keeping the state in memory, the state is also saved on local disk and replicated across multiple replicas. So this clearly gives you a higher level of reliability, with clearly a little bit of performance cost that is associated with the fact that the state needs to be persisted on disk. The state is managed, the state provider is a fully customizable interface. As you can see here in the slide, is a fairly simple interface. So potentially if you have specific needs where you want to save state in a specific storage infrastructure, I don't know, called DocumentDB or something else, you can actually implement your state provider, and at that point you just need to specify that state provider within the actor model, and then the actor model will use it. And then you have the ability also to control the state provider, either at the assembly level, so all the actors belonging to that assembly will use that specific state provider, or you can specify at the actor type. So one actor type might use a different state provider than another actor type. So let's have a quick discussion about scalability. So we discuss a lot about reliability, but what about scalability? So, you know, one of the key important feature of high scalable or cloud-ready type of application is the ability to scale. So the way that reliable actors scale is through something that is called partitions. And partition is a way to distribute traffic across multiple instances of your service. So let me I want to show you what that means. So let's assume, for instance, that I have, you know, in this case, 3 different clients application. They are going to call one actor. And if I have one partition, so basically I'm saying that I have a way to identify a range, okay, that basically says, okay, how do I want to distribute the traffic across this range? And then the default for actors model is basically a 64-bit integer that is used in order to identify sort of what we call the addressable space. So in this case, let's assume that I define my service with one single partition. So this means that basically no matter what type of ID I create, it will go through this single one partition. So is a funnel with one single output in a sense. And then this means that basically I have one single actor running in my cluster. Let's say that, you know, I want to scale. So I want to be able to handle more traffic. So what I can do is basically to define multiple partitions. At that point, the addressable range is split in 3 different buckets. And at that point, depending on the ID that I use, I might be able to use the actor belonging to partition number 1, partition number 2, or partition number 3. And then as my traffic increases, I can add more and more partitions in such a way that I have more actors or more services that are able to handle my traffic. So my traffic is basically spread across multiple instances. So let me show you what that means. So if I have this actor state, so the one that we were using before, so is already deployed. So one thing that I can do is, let me go to this stateful client. And then I have basically I have an application, and what I want to show you is the following. Actually, let me step back before I want to do one small thing. So I want to show you the difference between one instances and multiple, one partition and multiple partitions. So I have the application that I was using before. Let me open. This is the application manifest. That is basically what defines the application, as I was explaining before. So as you can see here, I have partition count equal 1. So this is basically the first case. I have all my traffic going to one single partition. Let me change that. And I want to say that, right now, my traffic is increased, and I want to be able to handle that increased traffic. So what I say is, now I want to run with 10 partitions. So there will be sort of 10 instances of my actor being able to handle the traffic. So let's take the application, redeploy it. So now I go through the deployment process. And then I go here. You see that that is still the old version. I have basically this one that is called, sorry, I need to refresh here. And you see that now there is a big difference. You saw that before I had only one of these entities, and these entities are partitions. Here instead, there are 10 of them now. So this means that basically I have now 10 different partitions that are able to handle the traffic. So if I have these 10 partitions now running, so let me see just to make sure everything is fine, yes. So if I go to my application, and then let's say that I have a num of counters, and let's say that I want to start with only, in a sense, 1. Okay, so in this case, sorry, I used the wrong command line. But what basically happens here is that I have 100, I create 100 counters. I deployed 10 partition. The service is deployed in 10 partitions. So as you can see here, basically the traffic that is coming from the client application is spread across the 10 partitions. So you see that each one of them is running one counter, and the traffic from the client is going to go to one of these partitions, and the counter is increased every time there is a client request. So as you can see, right now I have a lot of traffic, and the traffic is spread across 10 different partitions. So this is a way to basically show how a service fabric, an actor-based service fabric application can scale out, basically through what we showed here, that are the partitions. Okay. So let me kill this. Let's go back to the slides. And then a very quick recap, just to make sure that, we recap what I covered. So we have these sort of actors, that is sort of these independent units. So it somehow helps you to think about a highly distributed type of system. We saw that it's not that difficult to start. There is only 4 basic concepts in order to get started, that at the end of the day are not very different from a familiar design patterns like building an object-oriented type of application. The code and state are both reliable, so there is no additional code that you need to write in your application in order to handle those cases, failover and state persisted across failovers. And then it is also designed to scale. Through partitions, you have the ability basically without, and as you saw, I didn't change the code of my application. I just basically I just needed to change the manifest, the application manifest, some sort of metadata, redeploy my application. At that point, my application was able to scale much better. Okay, is that all? No. In addition to that, the reliable actor provides also some additional feature, and I will go through some of them. And then probably the last big question that you might have is, but how do I upgrade my service potentially without any interruption? And I will show you how to do that. So the reliable actors, the other features available in the reliable actors are, number one, very simple, as I said, these are very familiar design patterns. So actors are just quote-unquote objects, so you can take and then pass them around. Okay, it's very, very simple. And exceptions are also propagated. So from a developer point of view, it's a very, very familiar type of programming model. In addition to that, the reliable actors has a built-in garbage collector-like type of process. So this means that the framework is going to check if an actor was used, and if it was not used, the actor is marked as quote unquote inactive, and then the actual CLR.NET garbage collector can actually reclaim the memory. And this is done in order to optimize memory usage. The ability, since there is location transparency and at the same time actors are virtual, the fact that the garbage collector collects an actor and the actor basically disappears, it doesn't have any implication from a client point of view. When from the actor proxy, I'm going to call that specific actor. If that actor was collected because it was not used for a long time, the actor will be recreated, the state will be rehydrated completely automatically. So again, without any additional business logic that you need to write. And then the frequency of GC and the timeout, so how long an actor needs to be active in order to be collected, is something that you can customize. In addition to that, something that is very useful for this actor model is what we call timers and reminders. So those are features that allows you to schedule recurring tasks within the actor itself. And there is the big difference between timers and reminders. Timers are basically, they have the lifespan of a timer is within the actor lifespan. So this means that, for instance, the timer is active until the actor is active. But if the actor is deactivated, the timer will basically will be deactivated as well. So it's not going to fire again. Instead, the reminder is something that survives that sort of life cycle and potentially also failures. So if my actor is collected, or if my actor for any sort of reason fails and is restarted on a different node, a reminder is actually going to be active. So a reminder is at the service fabric level. So it's something that is persisted over failures. And then there is another feature that we call events. That is, the ability is a very simple pub/sub type of infrastructure that allows actors to communicate with a client application. So instead of typically to have the client to maybe do a sort of polling type of scenario where you actually query, the actors to get the information that you might need, you can register a typical delegate, and the actors can call that delegate on the client side in order to provide, for instance, status updates. So that is another feature that that is easier to build, that can make it easier to build end-to-end applications. Very quick note, since we are talking about single-threaded but in a multi-threaded type of environment. A quick note about concurrency and reentrancy. Reliable actors are turn-based execution model. So actors are executed, in turn, in a sort of thread pool-like type of mode. And then from a reentrancy point of view, it's basically based on a context-based reentrancy. So this means that, for instance, I have an actor A that is calling an actor B. The actor B is calling an actor C. The actor C can call the actor A because it's part of the same context, right? So that is something that is supported by the platform. At the same time, if, for instance, you want to you might see cases where you want to be able to detect this sort of loop back type of thing. At that point, you can disable reentrancy. At that point, an exception will be thrown if that sort of circular dependencies are happening while the application is running. In addition to that, because of reliable actors are part of the service fabric, they have some benefit in addition to that orchestration and resource is isolation. So basically this means that I can also control the placement of my actors. So I can decide where my actors are going to be deployed. I can decide that, for instance, the actors or the service that is part of my front end infrastructure is going to be deployed on one specific node in my cluster. Or I might have different type of services with different profiles, memory usage or data storage that I can place on different nodes. Think, for instance, a difference between I have a machine in my cluster that is using SSD versus traditional spinning disks. Okay, then There is support for full operations support. So in a DevOps type of scenario, when my system is in production, I have a wide range of different tools, health monitoring, cluster management, so see how my cluster is performing. You see the cluster explorer show me if the nodes, if they are healthy, what is happening in my cluster and so on. Those are all features that are built in the platform, so there is nothing that you need to do in addition in order to be able to have a sort of a rich production runtime type of monitoring infrastructure. There is a lot of emphasis on security. So for instance, you can have a fine-grained control over security and use different security profiles based on the type of data, for instance, that your actors or your Windows Fabric services are going to handle. So, actors that are dealing with untrusted data, you might want to isolate them on one specific node and run under a low privilege type of account. So this is all feature built in the service infrastructure. And then there is the life cycle. So along with the ability to, as I saw, to have reliable services, the service infrastructure provides also the ability to manage the application lifecycle. So, for instance, and something that I want to show you right now is the ability to upgrade your application without any interruption. So let's switch back. So let's kill this. If I go to here and then I want to deploy a new application. First of all, let me show you the code very quickly. I don't want to spend too much time on it, but just to give you an idea on how the code will look like. So this is a service. Is more, for the previous demo I use a console application. So this is more a real application where I have a web front end type of thing. So I have a service. Here I split the service in two different versions. So I want to show you how you can upgrade a service using the built-in features. There are the interfaces as you should be familiar at this point. And then there is basically this one that instead of being a console application is a web front end. So let me show you in the slides very quickly. So what that means, basically the architecture of the application. So I have a browser. What I want to show is I have a front end. In this case is a Project K front end. The Project K is hosted within the Service Fabric cluster. Is using multiple actors, and each actor represents a moving object that is moving in the browser. And I will show you what that means. The thing that is happening is basically the front-end application is going to push updates via WebSockets to the browser, and the browser in the canvas is going to update the state, actually the location of all the objects. And then what the front-end does, in this case, is to query all the actors in order to get status updates. In addition to that, the actors, within the actors, they're using timers as a way to update their location. So what happens is that every 30 milliseconds, a timer is fired, and then what the actor does is to update its location, and then the state of the actor is actually the location itself. So basically the state is persisted. So from a front-end point of view, what the front-end needs to do is just to collect all the data, send it to the browser. So it's a very simple type of front-end. Everything is managed within the actors in the cluster. Okay? So the application is here. I have, just to show you if you are familiar, this is a typical Project K type of application with controllers, views, and so on. And then the only thing that I see here is basically the way that if I look at this method is from within the actor is I'm querying the actors in order to get a status update. And then via WebSockets, I'm going to send a status update to the browser. So if I go here, what I want to do is, I have the application, I already prepackaged the application. So what I want to do is to run a very simple PowerShell script that using the Service Fabric PowerShell connects is going to take the two packages application and deploy them. Okay, so what I'm going to do is I said deploy. So what is happening is I'm connecting to my local cluster, and what Visual Studio already does built in, I'm basically deploying the application. In this case, I'm deploying both versions of my application, but I'm quote unquote activating only version number 1, okay? So you see that here I have basically 2 applications. I have version number 1 and version number 2, okay? And then the active one is right now version number 1. So if I open the browser and I go to my local machine on port 8506, and you see that I have this sort of very simple, let me zoom in a little bit. So I have basically what we call the visual object, or flying objects are moving around. You see that there is a little bit of a tail. The tail represents basically the state of those actors, and those actors are basically same their previous 50 positions, and then basically the browser is just rendering the current state of those objects. So if I go to my project Service Explorer, you see that I have a new application. Okay, the application right now, there are 2 services. One is the stateful service, that is the one that is managing all the actors, and then the box 1 is basically the project K front end. Okay, so and you see that here I have my project K front end is running on node 1, and then here I have my actor that are basically spread across basically 10 different partitions. Okay, so if I go here, and then the thing that I want to do is, you see that I have these flying objects, and while those guys are running, what I want to do is I want to do an update. So at this point I have the same command line tool, and then what I do is I basically trigger an update. So what this means is basically is telling Windows Fabric now, Service Fabric, now you want to move from version number 1 to version number 2. So let me go here, and then if I go to the Service Fabric Explorer, you see that basically what is happening is showing me, actually let me do this so we can actually see what is happening in real time, is basically telling me that we are going through an upgrade process. And you see here that I have different domains, upgrade domains, and what is happening is I'm updating right now the domain upgrade number 1. And then what happens is, if we keep looking at this, so actually let me move this here. If we keep looking at these objects, you see that while the Service Fabric is updating my service, some of these objects will stop for a second, and those are the objects that are running on that specific domain upgrade. So in the node that belongs to that specific domain upgrade. They stop for a second, as you see here, and then after the domain upgrade is completed, they will restart. The important thing to notice is that state is not lost. So from a client point of view, I see that momentarily they stop, and keep in mind that I'm running everything on one single machine, so clearly here is a little bit slower than it will happen on a real scenario. But as you can see, you know, the flying object will stop for a second. They will resume as soon as the node is updated. And at the same time, you see, if you notice, that actually the upgrade process went through, because now they are actually rotating. So actually the upgrade of my actors was adding rotation to the actor itself. Okay, so here you see that this is in progress. I have 3 out of 5 domain upgrades, and at that point, the goal here is to show you that you see that is happening. There is 0 downtime upgrade, so the client is still running with that. Okay, so we saw the demo, and then this is basically the end of my presentation. There was a lot of material to cover, so clearly I will invite you to take a look at our SDK. So the samples that you saw in my demo are part of the SDK, so you can run on your local machine and actually spend more time to look at the code. We are going to post more tutorials and videos soon, so keep checking these URLs, and there will be more and more material. And then, very, very important, please provide feedback. We have a lot of feature. The platform, the runtime, Service Fabric can be used for a while within Microsoft. There are big important services running on it. The actor model is relatively new. So if you think that there are missing features or there are scenarios that are not easy to implement using the actor with the feature that we have in the actor model today, please let us know, and then we will try our best to between the tech preview and GA to improve as much as we can. And then stay tuned, because again, as I said, documentation is going to be a living type of thing. So we're going to add more and more scenarios that will help you to understand the benefit of using actors for building new applications. Important thing, actors are not for everything. There will be a document that explains the typical design patterns and anti-patterns for the actor programming model. So that's it. I hope that was useful. Thanks a lot.